Welcome everyone. Welcome to our, cannot count how many what the fucking hours we have done anymore. But today we are gonna find out what the fuck is cloud native operations. We have today Pini and Michael, as I mentioned. And first we are gonna through some items with you. Oops, my slides. Oops. So some housekeeping. We have some announcements, then some gossip from the cloud native world. And of course, after that, we have Pini and Michael. So today, please note that we are recording this session. If this is an issue with you, let us know. We can cut your name out. Also, please follow our code of conduct. In summary, it is about being kind to each other and respectful to each other. Please feel free to contact me or Carla, my colleague here, who is helping me, and she is posting the links as I am talking. If you are feeling unsafe or see anything breaking this code of conduct, let us know. As this is recorded, we are going to post the talk on YouTube channel, and also we are going to be following up with you via email after the event. Please, please, we encourage you to ask all the questions. So now, we, of course, as some of you might know, we have written, and by we, I mean, obviously, Pini and Jamie and Michelle, they have written a book about cloud native transformation. And now we have a unique opportunity, or you do, to have get a free copy of this digital book. Carla, again, is sharing the link for you to download this. Then, our newsletter. So some of you might know, maybe some of you don't know, but we have a WTF newsletter. You can sign up. Again, we share with you different blogs and summary of the events, and this newsletter is on monthly basis. I think ours went just out on Tuesday this week. So you can catch the next one if you didn't sign up yet. And of course, now we have a big virtual event for hiring. In case you haven't heard, we have a 3-day full event to hire a junior and senior and mid cloud native engineers. If you want to find out more about this event, please, again, click on this link that Carla is sharing right now. And of course, hopefully Jamie will be back for the next event, but I think he has enough time. It's the 29th of July, same time, and we are partnering with James Form and Marcel Müller, where guys are going to talk about what on earth is Cluster API. I wish I can give you some more background, but I don't understand these things at all. So without further ado, we have some gossip. So Lian, I think.
Yes. Yes. Well, the first item of today's gossip section is Infinidash. I'm sure a lot of you have heard about it. Infinidash is an AWS service that now has become the newest, hottest thing on earth, or at least on AWS. The one thing that's a bit special about it is that it doesn't exist. So this started as, I think, a developer advocate. I don't know if it was Quinn, but someone there who basically made a bet that they could just come up with any kind of AWS service and recruiters would just put it on, you know, their job ads, and like salespeople would just go run with it. And yeah, they did. There were so many events around this. There was some kind of community event around Infinidash, and some influencers made some really interesting videos that were just a bunch of buzzwords. And I don't know, maybe some people still don't know that it doesn't exist. But this was a very nice I guess, social experiment and seeing what happens with, you know, these kind of buzzwords that pop up in our industry and how they just kind of like go haywire and develop a life of their own. Yeah, that's my topic. Next one is Adrian.
I thought Infinidash was a pretty good name, by the way. I'm quite impressed with the name in there. They've actually kind of thrown away a good name.
Yeah, he just made it up on the spot. I think he was just like, oh, let's just name it something like Infinidash. And it actually sounds more like an Azure service, I would say. Okay. But yeah, anyway.
Okay, so my one's on Linux gets crabby. Yeah, it's not actually about Linus Torvalds getting grumpy as per usual. It's actually about Rust getting into the Linux kernel, or Rust being used to develop Linux, and crab is, of course, a logo for Rust. Yeah, basically the idea is that if we can sort of start using Rust to develop Linux kernel stuff, then it'll reduce bugs and security vulnerabilities and so on. And they've taken pretty large strides, and they've got stuff merged into the Rust compiler that's sort of necessary for developing kernel code. And it's actually pretty interesting if you go and look at the changes that they need. I think the big one is to do with the allocator. So like normally in Rust, when you allocate memory, if it doesn't work, it just panics and exits. Because if you're developing application code and you can't get memory, well, that's it. There's nothing you can do. So the best thing to do is to panic and exit. But it's a bit different world if you're writing a kernel. You need to be able to see, did that allocation fail? And if it didn't, there's still things you can potentially do about it. So they got a whole bunch of stuff merged, and Linus Torvalds seems very positive about it. So it looks like in the future, you will be able to develop for a Linux kernel using Rust, which I think is pretty cool. Back to you, Leanne.
Thanks. Yeah, so I'm jumping in for Ian, who couldn't be here today, with the third topic, which is about GitHub Copilot. And I'm sorry that I just don't have the creativity to come up with great puns and great creative titles like Adrian does. But so in case you haven't heard of GitHub Copilot, it's a new feature where an AI will scan a code base, a repository, and then we'll be able to basically write the same code again in kind of the same style. So I think they did some experiments where they just had a function and they would just remove the function body, and GitHub Copilot pretty much just wrote the exact same code again. What's interesting about this, I think, is that there's also some questions about licensing, right? Because now GitHub, if you're on GitHub, you don't explicitly give permission for them to use your code as a like a data mining for the AI. So those are very interesting questions, I think, that will arise. And most interesting to us is when AI becomes like sentient and smart enough to write code for us, what else is there for us to do? Will we then just do YAML for the rest of our lives? Maybe, maybe not. We'll see how that works out. Back to you, Teresa.
Yeah, awesome. Thanks, Pips. This was really interesting. And see you next time. Alrighty, then now we have, of course, Michael and Pini. Pini, if you can introduce yourself quickly, and then you can start sharing and go ahead.
I'll do that. First, I actually entirely missed the Infinidash joke, so thank you for educating me. It just shows how I heard the name, only now it made sense. So that only shows how far into marketing I got instead of engineering. Okay, I'll share first, and then I'll introduce myself. So thank you, Teresa, and so yes, coordinator operations. So first a bit about myself. I'm Pini Reznik. I'm originally coming from software configuration management background and all kind of other things. I'm co-founder of Container Solutions and did all kind of different things. Most of the time I was the CTO, so on the technical side, but now I don't even get engineering jokes anymore. So that's how how far I get from there. I did write that book together with Jamie and Michelle. It will be mentioned later on in the story. So cloud native. Before going to operations, let's go into cloud native first. And you may already know cloud native is dynamic orchestration, microservices, containers, and all kind of other technical stuff. That's what people say, right? And of course, I can go into deep converse like discussion. I can invite Leanne and Adrian to help me to go and talk about every single piece of it in extremely deep technical details, but I'm not going to do that actually. So what I'm going to do instead is to ask why cloud native, and then how and what cloud native, and with some emphasis on operations. And I'm not going to go too deep into that, but for that we have Michael who will take it further into SRE specifically. So why cloud native? So basically, until now, the way we build our software, and most of the people these days build software the same way, is like this long-standing castles, right? A piece of software that longer it lives, better it is for longevity, right? So we build to last. And the general idea for that is you build it, you invest a lot of effort up front, it takes a lot of time, a lot of effort, a lot of thinking, preparation, planning, whatever. And eventually you get this amazing castle that serves you for many, many, many years. And you just incrementally improve it and make it slightly better. This works very well when you know 500 years up front which castle you're going to need in 500 years. And the way the process works is something like that. Let's say not talk about castles, but more like a home. So you want to build a home, you are the customer, you have this dream house in your mind, and you go to an architect, and the job of an architect is to get this dream house out of your head and put it on paper. So he can later hand it over to the construction team to actually make it happen. And at the end, you get the house, right? So the whole process takes, let's say, 2 years on average, and most of the budget, and actually a bit more than expected budget, goes into full construction. And you get 2 years down the line, the house that you wanted 2 years ago. And then you're stuck with it for 10 years because you have no money to switch and you have no money to improve or change, or effectively you live in a house you never, like you wanted in the past, but you never actually see the house you wanted in that specific moment where you move in. There are two major points in this process. The first is approval by a customer for blueprints. So basically handover from architect to construction teams. So there's a lot of planning and then handover. And the second is handover back to the customer. So the handover to the customer, that's where the architectural work ends normally in this type of projects. So it basically means that architect doesn't care what's going to happen after the house is finished. So this all works very well for static world where you can predict what's going to happen, but the world is not static at all these days, right? So the speed of innovation is increasing dramatically every year. So if in the past it took ages to switch from one technology to another, these days it's actually very happening very fast and actually faster all the time. So you can see in CNCF landscape lots and lots and lots of different tools. And this side, this CNCF landscape is very dynamic. New tools are coming all the time, acquired by others, they're replaced by, and they're all sort of adding something new to it, right? So something new to cloud native. And as much as it is scary for people who live in this world of, in static world, that the change is actually difficult, it is also an opportunity to improve, right? Every single tool gives a new angle, new opportunity to do something better in different ways and be better than competitors. So what happens though in these cases is that every time this new technology introduced and you want to switch to a new technology, you need to go through sort of Innovator's Dilemma. This is a title book of a book called Innovator's Dilemma. And the general idea is that you basically write certain technology. In the beginning, you adopt it, right? And then you get the value, and then slowly the incremental value decreases. So then you need to jump to the red line and then enjoy the growth again. But the Innovator's Dilemma element is when you need to go, basically that's the investment. So you need to go down in the value to get much higher later on by using new technology. So for example, you are using VMs and you deploy them with Puppet or something. Then you have Kubernetes, so you need to invest significant effort to switch to Kubernetes. But if you do, then you can go much faster and get a lot more benefits from it. You can be more competitive. So this is the basic principle of Innovator's Dilemma. But what happens is, again, the innovation is going faster and faster. So it's not just the world is more innovative, but the periods between disruptive innovation are getting shorter and shorter. So if in the past you can do, let's say, go through Innovator's Dilemma every 10 or 5 years, so you could spend a year or 2 years on going through technological change, drastic technological change. These days, you need to adopt new tools and new disruptive technologies every year, every 6 months, sometimes every month. So you need to leave, but spending a year on switching from one technology to another is just not acceptable anymore. Again, the reason is because we are not building those castles for 500 years or for 10 years. The software and the software we are building for the environment where we live is changing all the time. So basically, you cannot really predict the possibility which is change, right? It's different environment, different needs, different opportunities, but you can prepare for it. So you can be ready to adjust, right? Not use the right tool to guess what is going to happen in the future, and then choose the right tool now and install and deploy it and integrate it and then use it later on. So you are ready. But you can be ready to adapt anything that will be useful in the future, in that specific future world that we don't yet know what it is. So, okay, so the why cloud native is because the world is changing very fast. It was okay to build software for longevity. Now it's just not good enough because the world is changing fast. So how can we achieve that? Yes, so what we want is to build to change, right? So build software in a way that it is adaptable and can serve us in any upcoming situation, in any environment we are going to meet. So more like this like bunch of random containers stacked on each other. No one really cares about them, right? They're not beautiful. They are not, whatever is happening inside is not important. And if they don't serve you well, you just remove everything inside and you rebuild it towards whatever you like. Another example is food hallen in Amsterdam, and those things are all over the world these days. It's a massive hangar, former tram depot, and essentially it's not needed for trams anymore. That they removed all the trucks, all the stuff from inside, and they build offices and shops and food court. Next time the food court is not needed, right? They will remove it and rebuild something else inside. So this ability to change the purpose of the building is beneficial when the environment changing. And what defines the ability of a building specifically to adjust to the environment are two major elements. One is the foundation. So foundation defines how tall the building is, how heavy load it can carry, and the structure, right? The reason the food hallen, this tram depot is so good for, so adjustable is because it has no walls in between, right? So it's one massive space. You can divide it the way you like. That's why it's adjustable to any situation. So what happens often, for example, I live in a house, we have this supporting wall in the middle, and this supporting wall is very expensive to move or demolish because you need special permission, and you need to put some pole in the middle and basically rebuild half of the house. What it means is that this house is not adjustable to an environment. It means that I cannot, if I want to expand the living room and do whatever I want to do with it, it's not really practical because the house wasn't built for change, right? So the question really is how we can build software in the way like these large hangars that can easily be adjusted to any environment, any future needs that will come that we cannot even guess right now. So, and if we compare the way the buildings are, then the houses are built in this new changing world. So what happens is first, still, you sort of dream of your, you think of your dream house, then you go to an architect. So in the first case, the architect was just extracting the view from your head and putting it on paper. The job of the architect in new changing world is to try to evaluate all future scenarios, not one, but many. Essentially, try to guess as many possibilities in the future as possible, and then define the direction where we can keep as many doors open as possible. After that, there's still a blueprint, but only for the MVP house, meaning very strong foundation. Again, that's something that defines the future adaptability of the building. So if you, for example, want to build 7 stories building, but you only want to build first and second floor, then you still need the foundation that will support future growth, right? And then very small house that only serves your needs and immediate needs. And after that, you can continue improving and expanding and changing and adjusting the house. So what happens in this situation is that it takes, instead of 2 years, only 4 months to get to the point that you have a house you can move in. Yes, it's small, but it's enough in the beginning. And you always live in a house that you like and need, because once you have new needs, you can adjust the house, and you only spend maybe 40% of the budget to get to the MVP, or maybe even less. So you have plenty of money and time and different possibilities to basically improve and adjust it to what you really need. So to talk a bit more specifically about maintenance, right? So at the end, in the first case, the architect didn't care about the maintenance, right? Because the architects, like I said, there are only 2 points in time: the approval of the blueprints and handover of the house to the customer. Once the customer owns the house, then maintenance is their problem. And then we meet all kinds of different things like windows that cannot be cleaned. There's no space for pipes, so all kinds of different things that essential for normal maintenance and improvement, but the architect just didn't think about them because it wasn't relevant, because they don't think about the day after the house is released. So if you think in terms of software development, often enterprise architects would behave in the same way. They would design a house, a software system, and hand over to the customer, and then move on to design the next one. They don't care about maintenance. They don't care about normal operations, automations, or how easy it is to use for developers, right? So now, ongoing maintenance. So what happens normally, and that's again just sort of looking on the industry in general, not the most advanced companies, but sort of average. It happens when you have a support team and you have developers who need stuff from operations, right? So they need their products to be deployed somewhere, there need systems to be configured and all kind of servers to be provisioned. So there is a lot of demands coming from the development teams or from customers or from system failures or whatever else. So there's a lot of demands on the operations team to actually respond and improve based on feature requests or failures of the system, which leads to increasing pressure on the operational team. Right, so if you don't think how to operationalize software when you build it, then later on there will be increasing investment in maintenance, right? So you very often find this operational teams that are constantly firefighting, right? So basically they only respond to, or they only improve anything if something fails. They only improve if there is a request from the engineering team or from customer or from external forces, right? So the heroic firefighting becomes a norm. In this environment, no one thinks about real improvements. No one thinks how the software system can become better, how to consistently remove or find the sources of failure or basically invest in continuous improvement, right? So what it becomes is reactive maintenance, right? It's entirely 100% driven by external factors. So feature requests, failures, performance problems, things like that. When that happens, when 100% of the time of operations is spent on reactive maintenance, there is no time to improve things and they deteriorate even further. So essentially, it's a vicious circle that always gets worse. Or in a different way, essentially, if you wait until things break down, then you're always going through major repairs. And major repairs are expensive in terms of downtime or effect on users, but also in terms of cost of repair, right? So it's much cheaper to address problems when they are not really a big problem, right? It's if you're, for example, driving a car and there is a light that says there is no oil, it's much cheaper to fill in the oil instead of waiting until the engine blows up and then you need to spend thousands of euros to replace the engine. But even cheaper is to do preventive maintenance, meaning actually going every year to a garage and replacing oil before you get yellow light. So the cheapest way to do maintenance is preventive maintenance, is to not even anticipate the failure, but basically replace things before they get broken, which is actually quite often in software engineering, where I said, don't fix something that ain't broken. But this is not exactly true for all the other industries. All the other mature industries are routinely replacing parts of the system before it gets broken. Actually, no one wants the system to get broken, right? The airplane, we don't want to wait until it breaks down and falls from the sky, right? We want to repair things way before that. And for that, those things, they tell us what's wrong, right? They tell us exactly when something is not functioning or something is just about to break down. They give us warnings or even errors, right? This is how observability of the car is working, right? So the car also doesn't tell us that we are out of fuel after we run out of fuel, right? It gives you another 70 kilometers to go and find the refill station, right? So basically, we can learn from those industries and think how we can do operations in the way that prevents failure in the first place. It's not just reactive to major failures. It's not just proactive in the sense that we are finding the root cause, but it's even preventive in the sense that we just routinely replace things that have certain lifespan before we even consider them. We don't need to wait until they break down. So in the same sense, we don't need to wait with software systems to replace them. We don't need to wait until they don't function anymore. We can replace systems as while they are still functioning and producing value. So this is, again, how it's done in cars. You have these periodic inspections. The government force, well, actually, the car manufacturers, they force you to go every year or every 2 years to a garage and review all kind of things and replace oil and stuff. And if not, you lose the warranty, right? And the government also has annual inspection for road readiness. So they will test all these different things to make sure that the car is fully functional, right? So when you go to the road, you expect all the cars to have brakes, tires, and all kind of different things. They're all reasonably functional. And the cars are very reliable for this reason. And same with buildings and planes and boats and all kind of other things. There is a lot of ongoing inspection and replacement of parts and improvements before the things get broken. So the goal basically is to get to the point that we still do reactive maintenance. Things still get, they break down, right? Everything breaks down. So we can expect some level of reactive response to unpredictable events. There is proactive maintenance, which means when we do find an error, we don't just fix the symptom, but we find the root cause and go there and fix it so it's not happening again. And preventive is periodic inspections, which are basically, they're beyond proactive. They are to replace things that are not yet broken, but we anticipate they are getting close to their end of life. So how? Again, why cloud native? Because the world is changing fast, right? And we need to build software that can be adjusted to changing environment. How? We're first starting with oversized foundation, very strong foundation. And in software world, foundation is potentially public cloud, automation of infrastructure, CI/CD, agile processes, and things like that. So those are very strong foundation elements of very strong foundation that will allow to build sustainable and reliable software systems. And it's very important to invest in maintenance, invest before things get broken, and get specific budget and time allocated to maintenance. So what? Now is the time to talk about cloud native. So what are we building? We're building cloud native systems. Now, again, like I said in the beginning, most people think that cloud native is containers, orchestration, all these things, cloud tooling, service meshes, Kubernetes, Docker, microservices. All of that is true. All those are cloud native technologies. But if you think that it's the goal is to achieve, but basically deploy those technologies and use them effectively, and that's enough, then in our experience, it's not. It's not, because there is all this team, organization, processes, culture elements that come on top of technology. And if they are not aligned, if you're not managing the teams effectively, then the success of cloud native transformation will be very limited, right? So basically, it's sort of two major elements. One is cloud native technology, and the second is cloud native transformation or digital transformation. It's sort of not a precise term. What does it mean, digital transformation, right? There are many versions of that, like DevOps. Who knows what DevOps is? But just for sake of argument, everything that is not purely technology, I would call it digital transformation. And if you look at Boston Consulting Group research, which is one of the biggest research and consulting companies in the world, they very simply say that 70% of digital transformations fail or don't achieve expected value. And the main reason is because it is not done in a holistic way, right? So it's done mostly only approaching either technical or organizational or leadership or other elements, but not all the 6 elements. But they define it as 6 elements. This is very much comparable to the maturity matrix I showed earlier. Essentially, they say, if you approach technology, organizational change, people, culture all together, then the chance of success of digital transformation goes up to 81%. But if you ignore one of those factors, then the chance of success very quickly decreases. So at the end, to successfully adopt cloud native, you need to address technology, but also strategy and culture. So again, digital transformation together with cloud native technologies. That's the real goal. So improve the processes, become more agile, more collaborative, less hierarchical, and all the other things that are less technical. And most transformations fail because of this, because there is strong push to deploy to build microservices and deploy Kubernetes, while ignoring entirely that the application is delivered every 9 months. And CI process fails every day and everyone ignore them, right? The basic things, the test automation is not present. And the teams are structured in very siloed way. So all that leads to basically all these advanced technologies become irrelevant if your organization is not capable of using them. So it's all about mindset and culture. And culture is it's about people at the end, right? People, they use technology, they implement technology. So if you have people who don't know Kubernetes, yes, that's because they didn't learn the Kubernetes, but it's potentially because there are no processes or environment for them to learn Kubernetes. It means there is no experiments going on. There is no psychological safety potentially to try things that are not specifically in the Scrum backlog. So there is, if you have large development team and none of them knows anything innovative, you need to ask yourself not why they are not learning Kubernetes, but you need to ask yourself why your organization doesn't support personal development, why your organization doesn't support investment in education. Right. So eventually, culture is not something given. It's not something set. It's just things that you do every day, right? The relationships, shared goals, all kind of small things that you do, how you talk to each other, how you interact with different people, how you respond to CI failure. All those things come together as culture, and it can be changed. It's just difficult and long process. Right. So at the end, yes, we do digital transformation through cloud native technology. Right. So again, we are living in fast changing world. So we need to build things that can adjust to new environment very quickly. We do that by building strong foundation and adjustable structure. And we do it by building distributed systems, cloud native distributed systems, or cloud native systems using cloud native distributed systems using cloud native technologies. And we adjust the organizational culture and build teams that can support such transformation. And very quickly, last part of the presentation is the cloud native transformation itself. So assuming that you think cloud native is a good idea and you understand that it's not just technology, but also organizational change and generally digital transformation, then the book is all about that. Right? It's about how you actually make the change happen. And so generally, cloud native is difficult. Right? Distributed systems are inherently complicated. Right, that's why you need to, you cannot control them, right? So that's why you need to have a culture that can live in or you cannot get certainty by deterministic means of trying to predict how the system will behave. So you get certainty through consistent process, through experimentation, through consistent innovation, right? And so essentially, when you start the transformation, you sort of wonder, how can I go through it? And you don't know what to do about it. But okay, then you actually take the first step and you go, and then it goes sort of all over, right? Because it's a new field. You feel like maybe you know what you're doing, but normally companies we see engage in cloud native or digital transformation very quickly lose their way, right? They sort of struggle to achieve anything meaningful. And that can go for 1, 2, 3, even 5 years, even longer in some cases. So often we see companies that put 300 people or 100 people on digital transformation, and they try to build massive systems, but none of it works well. Eventually they figure out, most people eventually figure out, and then eventually later on they become like really good with it, like Amazon or Google or something. But this points to when you're sort of lost. The question is how to reduce the time it takes to get from point 1 to point 3. So from the point that you don't know anything until you are quite good. And generally speaking, with our way of working, basically, and that's what we have written in the book, is sort of 4 stages: think, design, build, and run. So think is not where you sort of look in future scenarios. You try to understand what are the business needs, what could be the business needs in coming years. Then you design and build the MVP of your system. Normally it's cloud native platform with all the key elements like CI/CD and agile processes and all kind of different team culture and things like that. And from that point, you continuously invest in improving the system and maintaining it. And you build the maintenance processes as part of original development. Right? And the goal is typically in the same stage is to identify current state, define the goals, why to move to cloud native and how to do it, and plan the execution. And these are the design patterns. I'm not going to go too deep into that. I'll show later a website where you can read more about this, or you can download the book and read about the patterns in detail. But basically, in this first stage of think, the patterns that we are looking at are dynamic strategy, executive commitment, defining the vision, and creating value hierarchy. So those are to basically pause for a moment, think what is really important for you before you actually start doing things. Then second stage is design, which is the place where we translate the vision into detailed architecture, build a team, create the functional MVP that is production ready very quickly, which is basically creating the base for future transformation, both on technological level and organizational and cultural level. Then we're talking about core team and psychological safety and MVP of the platform and design thinking for radical innovation. Again, more detail you can read later. And then we continue into build stage. That's where, so in the beginning, we have a bit of strategy and research and team building and building some POCs and eventually taking the MVP to production. And in meanwhile, we continue educating the rest of the organization to be ready for cloud native transition, both on organizational and technology level. Right? And then there's gradual migration. So not rebuilding the full thing, not rebuilding the monolith, rebuilding it in microservices, but sort of gradually strangling the monolith and strangling the monolithic organization, but also doing things like continuous delivery and looking into future horizons, not just working on the things that are important now, but also looking in the future, what are the next cycles of technological improvements that are required or expected. And the last part is run, which is making sure that the operations, although they can respond in a reactive way to whatever failure happens, and they can respond to demands in real life, but they're also proactive in the sense that they're fixing the root causes and not just the symptoms, and they're preventive, that they're proactively looking into things to be replaced before they get broken. So the improvement is not just as a response to failure or external demand, but it's continuous and intentional. And important thing there, things are measure what matters, SRE team, observability, automated infrastructure, and many others. And typical example of transformation, but I won't go into detail. So the world is changing and becoming more dynamic, and it's not about trying to predict what's going to happen, but it's preparing for change, being ready to adjust yourself to whatever happens. And cloud native is not just about technology, it's also about strategy, dynamic strategy, and culture. And those are the main elements of the transformation. So it's a combination of technology and people. And you can get the free book here. I think you already have the link in chat. You can find all the patterns on that other site, cnpatterns.org, and you can download the maturity matrix, empty one, if you like to use it in your own company. And that's it. And before we go to the next one, any questions?
So nobody posted any questions, but maybe somebody wants to unmute themselves. Be brave and ask Pini anything.
I will also stay here and you can ask later on after Michael's done. Is any questions?
There is something. The culture usually comes from manager or even upper to down. As an analyst myself, how can I help managers see the benefit of moving to truly cloud native?
This is very common challenge. It's what happens very often. We see it very often, and with our customers, is that there is bottom-up approach to change. Right? Engineers understand the benefits of working with Kubernetes, public clouds, and whatever else. And they say, this is very important. So we really need microservices. We really need to, they go to their managers and they say, really, microservices are very important. And the response is sort of like, huh? Like, what do you mean microservice? I like, why would they do that? And I don't understand. Why would they put like 3 million euro in like full rebuild of the company? Like, what is it going to give me, right? So it's a challenge for engineering teams to translate this transformation into business terms that can be that executive team, the more upper manager, understand and operate within those boundaries, right? It's very important to get the executive commitment. And in our experience, transformations have to be done by the entire company. So they have to be supported by upper management, by the executive team. But the language is dramatically different, right? They don't really care about Kubernetes, not really. I mean, some of them maybe have, like they heard from Gartner or something that it's super important, but really they care about speed of delivery, customer satisfaction, cost, computation, I don't know, things that are like business terms, like MBA terms. And I think the most effective thing that architects and middle managers and engineers can do to convince the managers to go for transformation is to try to convert the page from technical to business language. Right? That's what we try to do all the time, right? We speak to middle managers, technical middle managers, and the first thing we do is help them to sell it to their managers. Right? And for that, the language has to change. Yes, so I should try to speak in their language in the way more than ours. I mean, typically as middle managers and senior architects, their job is to connect business and technology. Their job is to be translators and connect those worlds, not to advocate for technologies in engineering, in executive setup, right? But also not bring just executive ideas into engineering without explanation, right? The responsibility of architects and middle managers is to speak both languages in the right context, right? You have to be able to convert, like to explain why investing now in microservices will pay off a year down the line or 2 years down the line. And this explanation has to be done not in terms of like, now we have microservices. I mean, it means nothing really on business level, but in terms of business value.
Perfect. Thank you, Pini. Thank you, Nahuel, for your great question. And I think we can go ahead with Michael now.
Oh, thanks. I guess you can hear me and I just get started. Thanks,
Yes.
Pini. You ate up a lot of my time, so I will speed up. Cool. That's me. As I said, I speed up. I work since quite a bit in IT, various roles, since almost 6 years, or around about 6 years at Container Solutions. At the moment, CCO, and I'm a cloud native ambassador. And today we are talking about a service management framework, which help you to get into this preventive part of a transformation. So SAE. Something up front, reliability is still everyone's job. So it's not the job of a SAE team. So when you wanna go SAE, it's not like an ops team takes care of operations or an SAE team takes care of reliability, even though they have it in their title, but it's still everyone's job. And I'm trying to dissect it a bit. First, we start with, does it come from, and how does it compare to what we know as DevOps, and then a bit more in detail. The origins are almost at the same, so DevOps started almost at the same time like DevOps, but it started at Google as an internal thing. They had production issues, scalability issues, and they thought, hey, what can we do about it? How can we scale our operations without all the time throwing people at problems? So they are software engineers, and out of this then came SAE. It's independent, so they have nothing to do, the two movements, with each other. So DevOps does not steal from SAE or vice versa. But of course, a lot of things are in common. The major difference, in my opinion, is that SAE prescribes how you can succeed in various areas of the service management framework, where DevOps is like, you should do automation, you should do CI/CD, you should do a lot of things, but does not actually tell how exactly. And SAE is a bit more prescriptive of that. How does it compare to each other? A DevOps team or a product development team is usually a cross-functional team with this infamous T-shape, people like deep experience in one area and then, well, less deep knowledge left and right, but of the surroundings of whatever I'm working on. Usually the teams are focused on end customer products or projects like product development or the like. A typical mantra is still, you build it, you run it. So whatever you build, you will operate it later. Automation is focused in DevOps about delivery, like full automation till production. Their KPIs are usually as well the business KPIs and optimize for them. They optimize, of course, lead time and value delivered, how fast and how much. And usually 80% of the work in such a team is development work. The rest is admin and other stuff. And they tend to do Scrum. Whereas on the other hand side, we have SAEs, is an engineering team with reliability as a focus, and why it looks so terrible, I don't know. They do platform engineering projects, but mainly it's an engineering team. They run infra and your apps or both. The automation is focused on operability, so like lowering the work involved in operating things. Their KPIs are service level objectives and error budget. We talk about this in more detail soon. They optimize, of course, for number of pages, everything which is operations and toil, and they want to lower it and optimize for mean time to repair. So if things are broken, that the recovery gets faster and faster over time. They do 50% operational work or toil and 50% engineering to basically keep the toil as low as possible. So the 50% is further improvement and paying down toil and manage toil to stay below 50%. That's the main difference. But why is SLE the latest fuss in our industry? However, not that new anymore. And why organizations move away from you build it, you run it, or DevOps. Let's assume a typical product development team that does DevOps is typically 2 pizza teams, 7 to 8 people, of 5 to 8 people big, and they should also do 24/7. That would mean if you have a team of 5 engineers capable and willing, because you can't force people really into doing 24/7 and being on duty. So you have 5 people capable and willing to handle on-call duty. That basically means in a normal setup with 1 primary and 1 backup, that everyone on this team would be on call almost every second week. So the idea behind this, you build it, you run it, was if you write code and you operate it, you put more emphasis on quality. I think that's a fundamentally broken idea. I've never developed software and then didn't pay attention to how I build it. And just because I have to run it, I'm not doing anything different on the development side. It might have been true for some, but I think the general mass of developers, it didn't help. And I think there's even a problem to this, which makes matters even worse. Let's assume you carry this pager, even though you don't get paged each night, but you sleep less well. That's proven that when you carry the pager and you know you're on duty, you're not sleeping that well anymore. If you sleep not well, the next day you can't concentrate anymore. Then if you don't concentrate anymore that well, quality suffers. Quality suffers, you get more pages, and this just goes on and on and on and on. So for me, on a larger scale, DevOps, so a team can't operate at scale a critical system 24/7 by themselves with keeping quality up. There might be some, of course, but on general mass, I don't believe that's a sustainable way of doing things. And then there comes SLE. The guiding principles of SLE is somewhat different. It's an external team like the ops team in the past, but with a bit more rules and other focus. So SLEs have the ability to regulate their own workload. We come to this, but it has to do with this 50-50 weighting of their work. They use service level objective and error budgets with consequences to also balance this tension between features versus technical debt. Also, we go into that. Of course, general idea is to make tomorrow better than today. So continuous improvement, and failure is an opportunity to improve. So also failures are artificially created in an SLE setup. So regulate, how do they do that? We mentioned already, or I mentioned already, SLOs. There are some other S's, but doesn't matter. Multiple SLOs are combined to an SLA, and then the contractual part is then the SL A, not I. So SLOs is what matters. This is what you define as an objective or a top line target for a specific part of your service or your service. So you say, hey, we need to reach this because everything below our consumers or users would hate us. That's it. That's your SLO. But in daily discussions, you should use error budgets. Error budgets is just the inverse of an SLO. In this example here, 99.85% is something where I say, hey, below 99.85, our users would be unhappy. My ultimate goal is, of course, happy users. So they buy more, do more, or like it more, whatever. So I have 0.15% budget to mess things up. It can also be, that's what I put as discomfort onto my users. What the error budget actually is, this usually needs to be negotiated between all the stakeholders. There's platform, SRE, and of course, product development. And they need to agree on it. Usually it is a discussion just with the product owner or the part of it. And the major difference is between everything classical. In the past, you had potentially SLAs, even internal ones, and were super happy if you had a month with 100%. And are like, hey, awesome, cool. We haven't had any downtime and any incident, awesome months. Here it's more like you should not exceed your target. So you should use your target. So your budget, it's like, I don't know, financial budgets or anything else. So you need to spend it for innovation, for testing out things, for, well, let's just try it out and see what happens. And if it burns, then revert it. I still have, if I'm within budget, all is good. If error budget is blown, then the discussion is different. Then you stop releasing, but releasing means new features. So this is the balance between features versus technical debt. So if your error budget is blown, the work turns into preventive maintenance, like paying down technical debt until the next month rolls over, or however you're doing it with your window. And then you continue on feature development. You should make it public. So someone consuming, for example, internally your service should know what they are consuming. So there's an SLO attached to it, and I should also see, hey, how is the service actually doing? The benefits of doing this is like there's a common incentive between, in the past, this tension between dev and ops. Now it's about finding the right balance between innovation and reliability of features versus technical debt. That you can manage this. If your target is too high, of course, then you won't spend a lot on innovation. Then it's more on stability and less releasing. So you will adapt it over time usually. The teams actually decide how to spend their error budget. So they can manage the risk themselves. This is the target, whatever you do with it, I don't care. If it's, as I said, if it's unrealistic, high or low, it becomes unattractive. So you adjust over time the SLAs, both. The teams become self-policing. So like they usually create some policies on what to do when certain budget is still available and what not to do anymore. One important aspect is it's a shared responsibility. That also means it's a shared error budget. So if there's a platform team, for example, and you are the DevOps team, and there's a SRE team, and the 0.15% is shared across all. So if a cluster upgrade fails and the whole thing blows up, well, that also eats into the budget of the whole thing. And because, as I've said at the beginning, reliability is a shared responsibility. It's not a single department's team's job. SLO is a bit more why it's a bad idea to go into the highest. There are only a handful of systems I can think of that should aspire the highest availability. So almost 100%, even though we know it's not possible. I mean, if you shoot people to the moon, we want to get them safely out and potentially even back. Medical devices, nuclear plants, there we would expect the highest availability possible. This one's, no one cares if there's a downtime of some minutes, seconds. Our websites, Pokemon Go, or, well, conference website. The main idea behind is no user, no real end user could tell the difference between 100% and 99.999, so the 5 nines. But it's a huge effort to make always the next leap. And then, of course, even though you would be potentially available, you can never tell if my private network is there or power cuts, things. There are so much things in between you can't control. So the effort is just something you should manage. The costs are quite easy, not the cost in itself, but to find the balance and make it visual. If you see on the slides, on the bottom, there is reliability, and the more reliable, the higher the cost. Quite simple. On the left side, that's the percentage of happy users. And at a certain point, you say, this is what I'm willing to invest to make that much people happy. And then the rest is like, okay, I could invest that much more, but it would cost, it only brings marginal improvements on happy users. And then this is up to you to figure out, it's up to you to figure out, do you want to invest, I don't know, 3 times more to make just 0.5% of your users happy? But if you have a too low target, of course, your user will hate you for unreliable. They might go to another company to purchase something. On the other hand side, if it's too high, your users will like it, but your business might go bankrupt. And you have a long time to market, features due to excessive things. The costs are tremendous. And people who have worked already in environments like 5 nines plus, you will hate it. It's frustrating. You can't get anything out anytime soon. So it's a thing. So this needs to be balanced, and it's a nice visualization. I stole it from Google, but it's nice to see that, I mean, it's not linear. At a certain point, you invest a lot of more money for marginal improvement to make your users happy. It's an effort to build such systems. And also you need to be technically capable of building such systems. So like if you look just at a few of them in the lower end of things, well, single deployments in a single availability zone would do the trick. With 3 nines already, you should, 99.5%, you should already be able to roll back. I mean, you have 216 minutes. Let's assume you don't even have a single outage, so 1 or 2 or potentially 3 incidents per month, and you're not cheating with planned or emergency maintenance, so like real, you need to roll back. You can't log into system, crawl logs, and then fix forward. You need to just roll back, because 90% of cases, issues come from changes, software, infra, what have you. So you need to be able to roll back. This already is a challenge for most companies, to roll back changes on all levels of the stack. So the effort comes quite high. So even on a 99.5, 99.9% level, that's already quite a thing to achieve. Click doesn't work. The next thing is, of course, well, you aim for something and then you continuously improve, which doesn't mean you should always up your SLO. You just get better at achieving it and know how your system behaves and build things around things. To get there, the most important thing is, I mean, shit will hit the fan. But if it hits, then the most important thing is a blameless postmortem. Pini also mentioned that already. So it's not about prevention, it's not an option. It will happen. If it happens, you need to find out why did it happen and not who did cause the issue. It's just why, and why someone, most of the cases, is also triggered by a person. But why was this person able to do so? Why did a system not catch it? Why was there no test? This kind of things. And everything else is pure automation. Most important, blameless postmortem. As I said, it's an opportunity to learn. But if you are operating on a quite high level and everything is automated, everything is catched with tests, so your humans aren't causing enough trouble and your budgets are not consumed, then it's also time to artificially create chaos. We use the term chaos engineering, but it's reliability engineering, which is done across all other industries since ages. It's done to stress a system, to see how it behaves under even unusual circumstances. And we try to do the same now with chaos or reliability engineering. What does it do? It injects failures, brings down certain things, and you define actually what it actually does and how and when. And by then, you force decoupling of systems, which is quite important when you build reliable systems. So bringing down one part of a service shouldn't have a triple effect across the rest of the system. For me, there are 3 levels to this. Beginner, do it in test, basically. And if something breaks, file a bug to whatever triggered it, and then it needs to get fixed. Advanced means use it in production, but do it during business hours so you have the safety net that someone can immediately jump onto thing or stop it. And then pro, basically do it all the time, 24/7 in production. You will find quite nice things. We had a good case with a retailer, one of the largest ones. Last year, we engaged with them. We introduced chaos, and it was the first Black Friday they have survived. So no single order was lost. That never happened before. So through disabling random things, injecting failures, a lot of issues were found on the architecture, on the software, on all kinds of areas. And then they just got fixed and they survived Black Friday. I like this example because it shows what an SAE should actually do. This is an example from Facebook. It's a Facebook auto remediation service. So what does this thing do? They process 4 billion notifications per month. In the meanwhile, I'm sure it's more. It's already 3 years old, this thing or something. It filters out a lot. You see the number. And out of that, of the remaining, 99.7% will get auto-remediated. This thing is developed and maintained by 2 SAEs, and they replaced 250 system admins that would have done all this manually. This is the engineering bit of an SAE. And they should focus on this to pay down all the manual toil operational load. That's operations done by an SAE. That's by their software engineers, by heart and trade usually. In a distributed environment, you can't solve an issue, an availability issue, just on the infra level. I've seen this now multiple times that people or companies go like, hey, we have availability issues, our app is unstable, let's deploy our infra over multiple availability zones, geographies, or even cloud, only to realize, oh shit, there's something like eventual consistency and other constraints that will not work. So we can't even deploy our application like this. As I've said, it's a joint effort. Everyone needs to work on availability. How to get started? The easiest, not the easiest, but a way to get started is you should know first, why do I need it? Does it make sense for us? That's basically the strategic goal. And then you define some architectural principles and design and delivery practices to follow. So to build on infra level, application level, well, reliable system. I stole this from Building Microservices by Sam Newman. There's in his book, you can read a bit more about this in his book. The first step then is you need to identify your failure scenarios in your architecture. Typical ones are service A is not able to communicate with service B, so like split brain, network interruption, something like this. Database not accessible. My application can't connect to the file system. A lot of things could go wrong. And then think about what happens if some of these things would happen. So like cascading failure. Oh shit, if A is down, B would fall over because that would be a cascading failure because I don't have exponential backoffs or circuit breakers or a pipeline in the middle, and then work to prevent those. A good start when it comes to application development principles of, well, practices is the original 12-factor apps. 12factors.org, I guess, is the website. You can read up on each of that. It's quite extensive. If you would follow that, it's already quite resilient application, partly as well infrastructure. It comes from the pivotal times of things where we did past systems. I would extend it by 3 more factors for being a bit more cloud native. That just adds a bit more to it. Because they didn't speak about composability, resilience, and observability explicitly. Yes, 12-factor net. Thanks, Pete. And observability, so expose the state of your application as metrics. Oh, almost done, quite fast. Site reliability engineers manage users' expectation or happiness. That SAEs are just there to keep the users happy, but maintain the balance between innovation and reliability, and not 2 different silos and one throws over the wall of 2 ops and then they need to keep the shit up and don't have influence on how it is done. This is where SAE comes in. They have influence with error budgets. They also work on the system. They actively develop parts of the system forward and not just keep the lights on as much as possible. Maintain all the things. And here, if you like more, to hear more about cloud native and potentially also SAE, we do a hybrid conference in November and you can register. There you go. And now I leave the stage for questions. I leave the slides. Let the slide there.
Perfect. Thank you, Michael. So we still have a couple of minutes for questions.
Yeah.
Perfect. If anybody wants to unmute themselves, of course, you are welcome to do that and ask the question directly to Michael, or you can, of course, post in the chat. Something that one of the participants asked, and now I'm not sure if it's a question for you or Pini. Do you have any examples of red flags that reflect that developers are getting too far into the operational or business functions?
I guess there is no too far. Simple answer for that.
Great.
It's good to know, it's good to see that they are doing on both sides. Anymore.
We'll give it a couple of seconds. Maybe somebody's typing away. Mm-hmm. Nothing. Okay. Well, if any questions still come to your mind, of course, you can tweet at us, you can send us an email, you can connect directly with Pini or Michael as well. I would like.
Hi.
Sorry. Yeah.
Hi. We might want to go through some of the other questions. So
Oh, yes, true, true,
Yes.
true. Yes, very good point. Thanks, Carla. I almost forgot. Great. So actually, there were some questions, yes, that were submitted at registration. So one of them would be how to fix container CPU throttling. Not sure how related it is. I apologize if it is not. I obviously have no idea. Any of you? No real answers? Do we want to follow up later?
Would love to answer that, but I
Go.
won't. No, I would love to. I don't know how.
Okay, another next question. How to incorporate security in cloud operations?
I mean, it's the same like with any function. It needs to be part of the whole, well, let's use software speech, value stream. It is an essential part, but it's not a loose coupled thing at the end with a gate. So whatever you mean by security, it needs to be part at the beginning. So on the creation already, principles and practices, how to develop secure code, how to do secure infra, this kind of thing. It can come at the end. So also security is an enabler, whether you make it part of the teams or you just create something that allows teams to consume security services easy. That's a bit up to detail, and usually it's quite, well, you need to decide whatever there is, but it needs to be an enabling function, not a blocker.
Actually, we had this conversation like yesterday, I think, with our friends in Cisco. And I think the main point here is right now, everything becomes automated, right? It's very important to understand that the delivery of the software from the development teams to production has no human handovers, right? I mean, theoretically, there could be something, but generally, you don't want handovers. You want to change the flow through the pipelines directed to production. And security is one of those things that theoretically, or actually very much practically, should block delivery to production if something is wrong. So, and it's very much comparable to the way the operations was done in the past. There was an operational team that gets handed over the artifacts and then deploys to production. And then security also needs to go and check if everything is right there. Now that is unacceptable in the modern world. Right? It has to be part of the process. It has to be automated. And there's a very, very strong connection to observability these days. Right? So essentially, for security people to understand if the application is secure, it needs to be embedded in the code. It needs to be embedded in infrastructure, and it needs to be visible, observable, and constantly show to the security people what's going on in the system. Only then they can decide if the system is secure. The other thing is that, in non-distributed systems on-prem, the main principle of security was premise security, right? Like perimeter security, I mean. And it means that if you protect the perimeter inside, everything is open and whatever. Do whatever you like because it's everyone has access to everything. Definitely unacceptable in cloud native world, right? Because everyone talking to everyone through internet, right? And it has to be secure. And so if you connect it all together, automation, instead of people checking things, strong connection to observability, very early way, addressing security concerns and embedding it in development practices, in tooling and everything else in very early stages. All this together, I guess that's the general direction of modern security.
Yeah, I agree very much with what have been said. I think the the Cloud Native Foundation has this security model with they call the 4Cs model. So they talk about security at the cloud level with the infrastructure and access to the servers and firewalling, and then they have the cluster level where you can do, for Kubernetes, you can do network policies and right now pod security policies and all that kind of stuff. And then the container level where you can do kind of image scanning and all that kind, and then the code level with the static code analysis and known vulnerabilities and all that kind of stuff. So there's some approaches to doing this, I think.
And that's on technical level. On organizational level, the security people are now enablers, right? Meaning that they need to help other engineers in all other teams to understand the security concerns. They need to create tools or introduce tools that help them to deliver faster without, handovers and whatever. So it's not, the technology is essential, those different levels and different possibilities and possibilities to block communication between microservices, things like that are very important. As important to embed security on organizational level and consider it as what is the definition of done? System has to be secure, right? That's a sort of more holistic approach.
And in general, reliability and security go hand in hand.
Yep.
If it's unsecure, it can't be reliable, and if it's not reliable, it can't be secure. This is like,
yeah. I think that's the realization that actually sort of core element of this is observability. Like you need to understand what's going on in the system, then you can decide if it's secure, reliable, or whatever other things that need to happen there.
Cool. Great. Thank you for sharing your answers and also your input, Thor. But unfortunately for today, this is all the time that we have. I would like to thank everybody who joined us today for your time. And of course, to Pini and Michael for their presentations. Big applause for everybody. And thank you, Carla, for your help today, keeping me on track and sharing all the links. And we will see you all in the next What the Fucking Are. Have a great day.